So in this video, what I want to do is just compare coal, petroleum, and natural gas briefly and touch on a few points that the article made. First of all, this is just a schematic sample diagram of coal. This is just one fragment of a much larger molecule. So I've drawn this as just having arbitrary edges, but really this thing should just continue on. So for example, uh, this part here might have more alkane branches that lead to more of these circular benzene-like rings. By the way, these things are called aromatics, any of these rings. So coal is an aromatic substance. When you look at this, it looks like one big two-dimensional substance, and in fact, it often does sort of come off in flaky sheets. Sometimes it's three-dimensional as well. But something that's relevant, because it has so many covalent bonds, this whole thing is going to be a solid at room temperature. One other thing, if we compare, they make a big deal in the reading about the carbon to hydrogen ratio, and that's actually a really important ratio in thinking about global climate change. So if you look at the amount of carbon compared to hydrogen, it looks to me like there's probably more carbon atoms than hydrogen atoms, if we remember that every single one of these is really a carbon atom. So the typical ratio for coal is 1 to 1, but again, in this case, it even looks like there's more of those coals than the hydrogens. Looking at a typical petroleum molecule in contrast, these are smaller chains. Sometimes they're just alkanes. Sometimes they can be branched alkanes. So like this is, what gasoline looks like, I believe. There's gasoline, that's isooctane. And sometimes they're more of there's aromatic rings, but they're much smaller. So this is benzene. We've seen this a lot. This is a component of gasoline. Sometimes naphthalene is in gasoline also. Typically these branch chains. Looking again at the carbon to hydrogen ratio, it's smaller here. It's pretty easy to tell what the average carbon to hydrogen ratio is. It's about 1 to 2. Again, that's a significant number. At room temperatures, all of these petroleum products, crude oil, tend to be liquid. And that's significant also. It means petroleum is super easy to transport. With coal, because it's a solid, you have to transport it by truck or much more commonly by train. With petroleum, you can put it in pipes and just force it under pressure through those pipes. And it will pour as a liquid. Last, natural gas. That one's really easy. It's obviously just methane. And so the carbon to hydrogen ratio here, you don't have to be scientists to figure this out, is 1 to 4. This thing is a gas at room temperature. Because it's a gas at room temperature, that's both good and bad. The bad part is that it is hard to contain. You actually have to constantly have it under, under a structure, otherwise it will leak out. And you often want to pressurize it in order to make it more dense. The good part of that is, since it's a gas, it's easier to introduce into a combustion engine or into a turbine to make electricity and have it evenly dispersed with the air so that you get complete combustion. Briefly about these carbon to hydrogen ratios. We're burning any of these things with oxygen, and the products are always just going to be CO2 and H2O. So if you think about it, really something that's very important is in controlling how much carbon dioxide, that greenhouse gas, the key thing in controlling how much CO2 we make is the carbon that's in the molecule. And the more hydrogen there is, the more H2O we're going to make and the less CO2 we're going to make. So coal per mole of fuel makes 1 mole of CO2. It also makes a mole of H2O, but it makes 1 mole of CO2. In contrast, with petroleum, we make twice as much hydrogen as twice as much hydrogen as carbon, so twice as much water as carbon, meaning that burning this stuff produces less CO2 compared to water. And then lastly, our methane over here produces even smaller amounts of CO2 compared to the amount of water we make. So it's the least carbon intensive of these three fuels.